My dear students, today we are going to discuss hydrogen chapter deleted topic. So in this chapter, deleted topics are preparation, properties and uses of hydrogen as well as hydrogen peroxide. In this video, today we are going to discuss about hydrogen compound, hydrogen element. So how to preparation of hydrogen? First one, how to preparation of hydrogen. Here hydrogen prepared by either laboratory methods as well as commercial methods. That's why today we are going to discuss laboratory methods. Zinc, laboratory methods here. First, zinc reacts with hydrochloric acid or sulfuric acid to form hydrogen. We are using dilute acids, hydrochloric acid or sulfuric acid to form hydrogen. So that's why here what is the reaction? Zinc reacts with dilute hydrochloric acid, form zinc chloride and hydrogen. Generally, here the metals which are occupy the position above the hydrogen electrochemical series. You know children, in redox reactions in the deleted portion I was sent one video in electrochemical series concepts. So in electrochemical series is nothing but here the arrangement of different electrodes either increasing or decreasing order of the standard electrode potentials form the series. That series is called a electrochemical series. What is electrochemical series? The arrangement of different electrodes, standard electrode potential values, increasing order or decreasing order to form the series. That is called electrochemical series. In this series, above the hydrogen, all the metals or displacement of hydrogen takes place from acids. So like that is why here in electrochemical series above the hydrogen what are presents? Here electrochemical series first A group elements like lithium, sodium, potassium, rubidium, cesium, and second A group elements nothing but alkaline earth metals, beryllium, magnesium, calcium, strontium, barium along with aluminum, zinc, iron, tin, lead, etc. These are some examples of here given here. These are all the metals are present above the hydrogen. So then in the reaction takes place, so here the reacts with dilute acids to liberate hydrogen. So that is why here what happened? Displacement of hydrogen takes place from dilute acids should be using here electrochemical series above the hydrogen of the metals. That is here examples are given children here. So then liberation of hydrogen takes place. That is one of the laboratory method. So like that here zinc, aluminum, tin, lead or silicon. Silicon is a non-metal which NaOH with NaOH or KOH on heating here gives the also here hydrogen gas is liberated. So now here the formation of the one of the byproduct here sodium zincate. Here whenever zinc reacts with NaOH. So like that here aluminum reacts with NaOH form sodium aluminate also. So like that here one of the product formed here hydrogen gas children. So these two are laboratory methods. Whereas here the commercial method. In this commercial method children observed here using electrolysis method. So you know what is mean by electrolysis? Electrolysis means the passing of electricity through the electrolyte in a dip into the electrodes also. Then what happened? Electrolysis takes place. So that is why in electrolysis process you are using the acidified water children. Which one? Acidified water using. So in acidified water you are in the presence of you are using electrodes, platinum electrodes. So what happened? The passing of the electric current, here acidified water undergoes electrolysis takes place. Here liberation of hydrogen gas as well as oxygen gas. Hydrogen gas is liberated to cathode, oxygen gas is liberated to anode. So now you have to show the reaction, cathode reaction children. Here H2O dissociates to first form, ionic form, H plus and OH form. So now here H plus undergoes reduction takes place at cathode, liberation of hydrogen gas at cathode. At anode, oxygen gas is liberated children. So this is the reactions takes place in electrolysis of acidified water. So that is why your hydrogen gas produced at cathode, oxygen gas produced at anode. This is one of the method for the manufacture of hydrogen gas by electrolysis method, children. And one more method also there, children. We are using another method is called here electrolysis of brine solution, which is here using electrolysis of brine solution. Brine solution is nothing but, children, here 10% of sodium chloride solution is called brine solution. Now again here also, here sodium chloride solution acts as electrolyte, passing the electricity through electrodes. Then again here what happened? Here formation of the products are sodium hydroxide, chlorine gas, and as well as hydrogen. So here three products are obtained, children. So in this electrolysis process, what are products? Sodium hydroxide, chlorine, and hydrogen. That's why here this method is also used for the here manufacture of sodium hydroxide as well as chlorine and hydrogen also. So what are the reaction takes place, children? Observed here. You are using 10% of sodium chloride solution, nothing but 10 grams of sodium chloride dissolved in 100 grams of solution. So or 90 grams of water. So together solution formed. So now here means 10 grams of sodium chloride only. Remaining 90 grams, which is there here? Water is present. That's why here by passing the electricity, sodium chloride dissociated into sodium ions, chloride ion, as well as water also dissociated into H plus and OH minus ions. Now here two cations are there, two anions are there. Both the cations are reached to cathode, children. But here preferable to H plus ion is undergoes reduction takes place, children. So according to discharged potential values, here H plus is preferable. Therefore here H plus ion undergoes reduction takes place. What happened? At cathode, children, hydrogen gas is liberated, children. So that is the your requirement of your preparation of or manufacture of hydrogen gas by using brine solution. Another byproducts, children, here chlorine. Cl minus undergoes here oxidation, chlorine gas is liberated. As well as your chlorides and OH minus ions reach to anode. But here chloride ion is undergoes oxidation, liberation of chlorine gas, children. But what about remaining ion, children? Here sodium ion is present, OH minus ion is present. These two ions are again combined together to form one more product, children, here sodium hydroxide. Is it clear? So now here what are the products formed here? At cathode hydrogen gas, at anode chlorine gas, and cathode also one more product here sodium hydroxide is formed, children. So these are the three products are obtained, children, by the electrolysis of brine solution. Next, children, here one more method using reaction of steam. Here reaction of steam on hydrocarbons or coke. Here using with hydrocarbons or coke with steam at high temperature, as well as you are using one of the catalyst, children, nickel catalyst also using. So you are using hydrocarbons. You know general formula of hydrocarbons of alkanes. What is the general formula? CnH2n plus 2. Here action with steam, n moles of steam. The reaction takes place at nickel catalyst and high temperature around 1000 degrees Celsius temperature. Then here the formation of the product, children, here. Which products are formed here? Here one of the product is carbon monoxide and here formed hydrogen gas. How many moles? N moles of carbon monoxide, 3n plus 1 moles of hydrogen gas is liberated. So that is the general reaction for the action of hydrocarbons with steam, children. Next, children, here action with hydrocarbons on steam. Here what are the products here? Carbon monoxide and hydrogen. So this mixture of carbon monoxide and hydrogen, here one of the specified name is there, children. That is called water gas. What is that? Water gas. Here water gas is one of the fuel gas, children. Water gas is one of the fuel gas, children. That is here fuel gas. So this water gas is also called, children, what is that? Syngas or synthesis gas. And next it is also called, children, blue gas because of it burns with blue flame. That is what is called blue gas. Here used for this water gas used for the synthesis of many hydrocarbons. That's why this gas is also called syngas or synthetic gas. What is that? Synthesis gas. Synthesis gas in short form, your representation as syngas, children. So what is the blue gas, children? The mixture of carbon monoxide and hydrogen is called blue gas. Why here it is also called blue gas? Because it burns with blue flame. Why it is called syn gas? Because it is used for the synthesis of hydrocarbons like methane, methanol, ethanol, like that, aldehydes, ketones prepared by using this mixture of the compounds. That is why it is called syn gas, children. Next, children, one more point here important. Coal gasification. What is meant by coal gasification? Coal gasification means process of producing syn gas from coal. Producing of syn gas from coal. So, producing of syn gas from coal means here coal, nothing but carbon, treated with water. Again, 1000 degrees Celsius temperature and nickel to form carbon monoxide and hydrogen. So, here the carbon monoxide and hydrogen mixture is called syn gas. So, this process is called coal gasification. So, some children, just important, ask the reaction. What is the coal gasification reaction? Means should write this one reaction. What is coal gasification reaction? Coal or coke treated with steam in the presence of nickel catalyst to form water gas. That is called coal gasification process, children. Next, children, one more important point here. Water gas shift reaction. So, water gas shift reaction means, children, here the production of hydrogen can be increased by reacting carbon monoxide of syn gas mixture with steam in the presence of iron chromate as a catalyst is called water gas shift reaction. So, what is water gas shift reaction? Increasing the yield of syn gas, increasing the yield of hydrogen gas. Increasing the yield of hydrogen gas. Here the syn gas mixture of carbon monoxide heated with steam in the presence of iron chromate, children. Here producing of excess hydrogen gas is formed. That is why your product will be increased by using water gas shift reaction. Is it clear, children? So that is a water gas shift reaction, children. So these are the methods of hydrogen preparation, children. Next goes to children here. What are the properties of hydrogen? Here, the properties of hydrogen. So hydrogen is a colorless, odorless and tasteless. And also it is a highly combustible gas. Highly combustible gas as well as lightest gas also, children. That's why it is a lightest and combustible gas, children. And also it is insoluble in water. Insoluble in water. So these are especially physical properties of hydrogen, children. And also here hydrogen is a very high bond dissociation enthalpy. What is that? High bond dissociation enthalpy. Around how much? 436 kilojoules per mole, children. So, it is the highest for a single bond between two atoms of any element. Like here, between two atoms of single means H2, single bond formation F2, Cl2, Br2 comparison. Here, H2 is the high bond dissociation enthalpy. Because of F2, Cl2 also forms here single bonds only. But O2 and N2 are triple bonds formation. That is why whenever comparison of your single bond formation of the elements like chlorine, fluorine, bromine, even iodine, your hydrogen is the high bond dissociation enthalpy. So that is why, children, here it is a chemically inert nature at room temperature only. But whereas under conditions of pressure, temperature as well as catalyst, here the chemical reaction takes place, children. Now that is why I am supposed to discuss what are the chemical properties. What are the chemical properties of hydrogen? Here the first of all, your reaction with halogens. That's why you are using the formula X2. Here X2 is nothing but halogens like fluorine, chlorine, bromine, iodine. So what happens, children, here? Hydrogen reacts with here halogens of X2, the product formation, representation, hydrogen halides. That is general formula HX. So now children, the order of reactivity of the halogens also, here fluorine, chlorine, bromine, iodine. The gradually, what happens here? Decreases. Here fluorine is a highly reactivity nature children. That's why your hydrogen reacts with here fluorine even in the dark place also takes place. But chlorine reaction with hydrogen takes place only in the presence of sunlight or UV light. But bromine, the reactivity is takes place only in the sunlight as well as your temperature also needed children. So that means to understand the reactivity gradually what happened? Decreases fluorine to iodine. So this is the general reaction is given children. H2 plus X2 gives rise to hydrogen halides. Next children, here action with metals as well as metal oxides. Metals and metal oxides. See children, here reaction with metals what happened? Hydrogen reacts with metals like sodium. What happened? Form the hydrides. Like aluminum reacts with hydrogen to form the hydrides. Aluminum hydride, sodium hydride. So the metals reacts with hydrogen. The formation of the compounds are called here hydrides. Example here given sodium hydride and aluminum hydride. Like metal oxides also, here representation of the general formula observed children here. Y moles of H2 reacts with MXOY gives rise to here X moles of metal and Y moles of water molecule is formed children. So the example is can taken as children here. Hydrogen reacts with here cupric oxide COO. The product formed here copper metal and as well as water molecule. So like that can you choose the metal oxides here reacts with hydrogen. What happened? The formation of the products are here metals as well as here water molecule. Is it clear children? Next children, the same principle you are also using here extraction of the metals children like that. Because of in this reaction hydrogen acts as a reducing agent. It reduces metal oxides to corresponding metals. Especially this is application is using metallurgy children. Extraction of the metals like here using of the extraction of the metals so tungsten, here molybdenum, purpose also your extraction of the metals you're using this principle only children. Next children, here action with organic compounds. So organic compounds means you are given some examples of reaction children. Here aldehydes, here reacts with hydrogen, here what happened? Converted to alcohols. That means what happened children here? Aldehydes are here reduction takes place converted to alcohol. That means here hydrogen is acts as a reducing agent children. So therefore hydrogen reduces aldehydes to alcohols like ketones to alcohols also. And also here one more example children, you are using ethene. Here ethene addition with hydrogen presence of nickel catalyst to what happened here? Formation of ethene. So here hydrogen gas is used in synthesis of many organic compounds also children. Yeah, that's why here show the some of the examples of here action with the organic compounds. What happened? Here the process takes place here, reduction takes place. Next children, uses. What are the uses of hydrogen? Here hydrogen is mainly using for the synthesis of some industrial chemicals. What are industrial chemicals children? So what are industrial chemicals? I give you some examples here. Here manufacture of ammonia by Haber's process. Here using one of the reactant element is hydrogen gas children. So that's why here nitrogen reacts with hydrogen in presence of iron molybdenum. Here iron acts as a catalyst, molybdenum acts as a promoter to form ammonia. So this is one of the principal equation in the manufacture of here synthesis of ammonia children. Like here synthesis of hydrochloric acid, here using the equation H2 plus Cl2 gives rise to hydrochloric acid. Like that, here synthesis of methanol CH3OH. Here also, what happened children here? Water gas, nothing but carbon monoxide plus hydrogen. The carbon monoxide plus hydrogen nothing but water gas. This water gas is treated with hydrogen. That's why I write the directly 2 moles of hydrogen children. What is the mixture here? Water gas plus hydrogen. Water gas means CO plus H2 plus hydrogen. Then what happened total? This mixture is CO plus H2, water gas and hydrogen total. Here CO plus 2H2. That's why right here CO plus 2H2. So in the presence of chromium oxide form the methanol. And next children, studied in 10th class also, here unsaturated vegetable oils, here hydrogenation, that is the addition of hydrogens in the presence of nickel catalyst or palladium catalyst or platinum catalyst. What happened children? To form the fat. So this process is also called children hardening of oils. What is the name? Hardening. Of oils. Hardening of oils. So this is especially used for the production of vanaspati. Production of vanaspati is one of the fat. That's why hydrogenation of oils, you're using the catalyst is nickel, platinum or palladium children. Here what happened? Unsaturated vegetable oils are converted into fat. In this process also using hydrogen. So these are some of the examples of here synthesis of industrial chemical children. So the one of main here synthesis of industrial chemicals, one of the use children. Next children, here main second use is about here hydrogen. What is that? Second one use, hydrogen is used as a fuel. What is that? It is used as a fuel. Why? Because here combustion with pure oxygen to give a large amount of heat, around 242 kilojoules amount of heat. That's why in industrial fuel it is called industrial fuel children. Now due to high heat of combustion, how much here? 242 kilojoules per mole. So it means 1 mole of hydrogen combustion to liberate 242 kilojoules amount of heat. That's why here it is one of the industrial fuel children. So now here hydrogen bonds with pure oxygen gives the large amount of heat. That is, heat is called oxyhydrogen blowtorch. What happened? Oxyhydrogen blowtorch. Because of your hydrogen and oxygen combines together burn to form the large amount of heat, around 2800 degrees centigrade temperature produces. Especially this flame is used for the welding as well as melting purpose like platinum, quartz. These are high melting points. So these metals are melted by using your oxyhydrogen blowtorch. It produces around 2800 degrees Celsius temperature children. That's why here used for the welding purpose as well as melting of the metals children. Next children, it is also one of the constituent fuel. Hydrogen is one of the constituent fuel in the gaseous fuels. So many gaseous fuels are available children like water gas, semi-water gas as well as here carbureted water gas and coal gas. These are the examples of some of the fuel gases. So in fuel gases, the one of the component is here hydrogen only. So water gas component is CO plus H2. Like semi-water gas means CO, H2 and N2. Carbureted water gas means CO, H2 as well as hydrocarbons. Like that, coal gas is also composition of one of the component is hydrogen gas only children. So in coal gas, here very highest calorific value around 21,000 kilojoules per meter cube children. How much here? 21,000 kilojoules per meter cube. So here one volume of here coal gas producing here efficiency is how much here? 21,000 kilojoules. So means the efficiency of the fuels always measured in calorific value. So that's why which is the highest efficiency? Coal gas is the highest efficiency because it is around 21,000 kilojoules per meter cube children. So now in this coal gas, what are the compositions are present children here? So your major component is children your hydrogen only. 45 to 55% hydrogen. Methane is 25 to 35%. Carbon monoxide is 4 to 11% children. So these are the composition of coal gas. Okay children. Next children. This gaseous fuel also converted into liquid form. Especially the liquid form of hydrogen is used as a rocket fuel children. What purpose here? The liquid form of hydrogen gas used for the rocket fuel. Okay children. So next children. So that is the use of hydrogen in fuels. Next children, one more here use is fuel cells. So nowadays hydrogen is also used in the fuel cells. So the fuel cells means children here what happened? Chemical energy is converted into electrical energy. What happened? Chemical energy converts into electrical energy takes place. So here combustion of the fuels like hydrogen is one of the combustion fuel, methane, carbon monoxides or examples of fuels. These fuels are combustion directly converts into electrical energy. So your fuel cells are best fuel cells children. Here free of pollution as well as your producing of current is more means more efficiency as well as here producing of electricity is more efficiency, free of pollution, transportation is very easy, but here the required raw material is less. That is why you are not preferable in the here manufacturing of electricity. Here means producing of electricity by using fuel cells. So whatever here, your hydrogen is one of the fuel cell children. So what happened in fuel cells? Directly converts electrical energy from chemical energy to electrical energy. Here the best example of your children here hydrogen oxygen fuel cell. So whenever construction of the fuel cells here what are required here? Fuel is required, oxidant is required, electrodes are required, electrolyte is required as well as sometimes catalyst also required. So these are the requirements of the materials for the construction of fuel cell children. In hydrogen oxygen fuel cell, here hydrogen acts as a fuel. Here oxygen is acts as a oxidant. Here using electrodes are porous carbon electrodes children. Porous carbon means it consisting of a small or tiny holes of the material acts as a electrodes. As well as a required electrolyte also. That purpose are using concentrated NaOH or sometimes concentrated KOH also using. Here based on the here using of the fuel cells need for catalyst also. In this process using the catalyst are children either nickel or nickel oxide acts as a catalyst children. So just I go through the reactions what are takes place in this process children observed here. Here the reactions are takes place electrode reactions are takes place here at cathode. Here using of oxygen that is oxidant. Here the what happened? Oxidant means self-heat undergoes reduction. That's why at cathode your oxygen gas undergoes reduction takes place. Here what happened? Formation of hydroxyl ions. Next anode. Here using of the fuel that is called hydrogen gas. Here hydrogen gas at anode undergoes oxidation takes place to form the water molecule children. Now here observe the reactions, both of them here add together, you will get the net reaction children. So what is the net reaction here? H2 plus O2 gives rise to H2O. In this reaction observed children, so what is the net reaction here? Formation of 2 moles of water. In the 2 moles of water in this reaction, so how many electrons are participate children here? 4 electrons are participate, nothing but 4 moles of electrons for 2 moles of water. As per ratio, here 1 mole of water formation, here involving how many moles of electrons? 2 moles of electrons only. How many moles? 2 moles of electrons are sufficient. For the formation of 1 mole of water, 2 moles of electrons are required. Is it clear, children? So, in this process, here what happened? Conversion of chemical energy into electrical energy, as well as the formation of pure water also formed, children. Especially the formation of the pure water is used for the drinking purpose of astronauts, because of in the first time hydrogen oxygen fuel used in Apollo space programs. So that's why here astronauts are used for the drinking purpose of here the formation of pure water, children. Next, children, in metallurgy is also one more application. In metallurgy process, here what happened? Already previously discussed here. Here hydrogen is one of the important here extraction of the metals, because of here it acts as a best reducing agent. So especially here tungsten metal or molybdenum metal extracted by using here hydrogen is a reducing agent. Here the corresponding compounds using, children. Whenever extraction of the tungsten, the corresponding compound you are using tungsten oxide. The tungsten oxide, what happened here? Here reduces to tungsten. So that is why here hydrogen is acts as reductant, children. So like that, whenever extraction of the molybdenum, the corresponding molybdenum trioxide here reacts with the hydrogen. Molybdenum trioxide is reduces to molybdenum metal, children. So these are the some important applications of hydrogen, children. So this is about the regarding in this video I discussed hydrogen element, children. Preparations, properties, as well as uses of hydrogen, children. Okay, children.